to welcome back to part 2 of your review session for your assessment that is going to be starting on Friday the 20th, and then you're going to hand in that assessment on Monday the 23rd. Okay? So part 2 of this review is going to be looking at identifying and predicting single displacement reactions. Okay, so this worksheet I've already emailed to you guys. It has a ton of stuff. It has an activity series that you can use, but there's also an activity series already uploaded on PowerSchool Learning that you can use as well. But there's the answers to the practice problems. And yeah, so there's a ton of practice on here if you feel like you really need to use it. Okay. I'm going to go over probably 3 or so problems, and then I'll leave the rest up to you guys. So we're going to get started. So I would like to get started with number 1. Whoops, pretty straightforward. Oh, actually, I need to get my activity series very quickly. I'd like to use the one that I gave you guys. Where is it? Solubility matrix. Aha. Here it is. All right, so this is the solubility matrix that you guys have, so I will be referring to this throughout this review video, okay? So if we start with, number 1, there we go. All right, so number 1 is going to be a reaction between silver and potassium nitrate, okay? So remember that single displacement reactions are metals replacing other metals. So in this case, we are looking for silver to replace potassium, okay? In a single displacement reaction, it's always one metal or one positive ion that's replacing another, okay? So that is a single displacement reaction. But we need to use the activity series to make sure that that reaction can actually happen, okay? So the way that this activity series works, I'm kind of upset because I had a really cool video for you guys yesterday that I made on my iPad, and then it just did not work whatsoever. I want it to be a colorful color. All right, well, anyways, so when I look at the solubility matrix, I'm going to look at my 2 metals of interest in the actual problem. So in this case, it's going to be silver and potassium. So I'm just going to kind of highlight those very quick. Silver, which is right, oh, that did not work. Well, so much for that. I'll just do this instead. All right, so I have silver, which is right here. Whoops, that was a really bad arrow. And potassium, which is way up here. There we go, okay? So I'm gonna look at my 2 metals of interest on the activity series, and the rule for the activity series is metals can only replace other metals that are below them on the activity series. So potassium can replace all of these metals down here, okay, all the way to the end, all right? So that is a go, all right? And silver can replace mercury, platinum, and gold because those are the only metals that are below silver. Okay, so that would be okay. But if silver is trying to replace potassium in this case, potassium is way above silver, so this would not work. Okay, so if you guys remember that when we look at single displacement reactions, the metal that is by itself, in this case, it is, silver, all right? That is going to be doing the displacing. So silver is going to try to displace potassium, but as we saw on the activity series, it can't because potassium is way above silver. So all I would write for this reaction is no reaction, or NR. Okay, so that one was easy enough, no reaction. All right, so I'm just going to get rid of all this stuff so that we can do another practice problem. Okay, so I will do a couple more and then leave you guys on your own to practice. Okay, so let's look at, what do I want to look at here? A lot of these have transition metals, which I do not like. I don't like any of these. Just kidding, you'll be fine. All right, maybe I should try number 11. Let me see here. Perfect. So I'm going to try number 11, and that'll be the last problem that I do. But remember, if you have any questions on these, the answer sheets are on here. Don't just look for the answers and be like, oh yeah, I understand it. If you really don't understand it, please email me so I can help you. I'm also going to try to set up maybe a Zoom session, which is like a video kind of conference thing, but we'll see about that, how far we get. All right, so in this problem, I have aluminum and I have lead. So those are my metals of interest here. So I'm just going to highlight those, okay? So actually, I wonder if I can highlight on this document. I can. Perfect. All right. So those are my metals of interest here, aluminum and lead. All right, so I'm going to go to the activity series, see if this reaction is going to happen. So aluminum is right here. Remember, it's by itself in that equation that we saw. All right, lead is down here. Okay, so aluminum's by itself, it's going to be doing the displacing. So aluminum can displace anything that's below it on the activity series. So it just so happens that lead is below aluminum on the activity series, so this is a go ahead. All right, so that means the reaction is going to happen and that we need to predict our products. So all that's going to happen in this situation is aluminum is going to pop right into lead's spot. I'd like this to be a little smaller. And lead gets kicked out, unfortunately. All right, so now my products are going to be lead, oops, PB, or peanut butter as I know you guys like to call it, and looks like a 3-year-old wrote this, aluminum nitrate, okay? All right, so remember when we predict products for a chemical reaction, we want to make sure that the formulas are correct. Okay, so balancing a formula and balancing an equation are two very different things. All right, when you balancing an equation, most of the time your products and your reactants are all there. So it's pretty straightforward. But before we need to balance this equation, we need to make sure that the formulas are balanced for our products, okay? So we need to make sure that all the charges even out to 0. So if you can see in this first part of the equation, it looks like we have nitrate, and that has a charge of -1, and then lead, okay? So lead normally you wouldn't know the charge of, but since it's bonded to nitrate, I can see that there's 2 nitrates, each has a charge of -1. So that's a total negative charge of -2 from each nitrate ion, okay? But that means that Pb, or lead, has a charge of +2, okay? And charges carry over from the equation, okay? So if lead is charged to +2 over here, it's also going to be +2 over here. Okay, you don't need to write +2 for lead, but I'm just letting you know that charges carry over from reactants to products. You don't change the charges, okay? And then we have aluminum nitrate. If you look at your periodic table, you should have this filled out. You'll see that aluminum has a charge of +3. All right. Nitrate has a charge of -1, and you can figure that out by looking at your polyatomic ion sheet, okay? So if I have a +3 charge and a -1 charge, unfortunately, +1 or +3 -1 does not equal 0, okay? And I want them to equal 0. So all I'm going to do is I'm going to put a parentheses around nitrate and put a 3 right here, because that lets me know that there are 3 nitrate ions for every aluminum atom, okay? So now what I'm going to do is, now that I have the formulas, okay, at this point the formulas are set, all right? As long as they are correct, when I'm going to balance this chemical equation, I'm not going to change any of these subscripts, okay, because the charges for each individual compound are balanced. And now it's time for me to make sure that there's an equal amount of each atom on both sides of the equation, okay? And I reviewed that in the balancing chemical equations video, all right? So right now, it looks like I have aluminum, I have lead, and I have nitrate. Remember, try to keep the polyatomic ions together when you balance. Nitrate, okay? So I'm just going to count to see how many atoms are on each side. Aluminum, there's 1 on each side, so that's good news. Lead, there is 1 on each side, also good news. But nitrate, we have 2 nitrate atoms on the left side, not atoms, ions, and then 3 on the right side, okay? So kind of like in the last video I did, you're going to want to balance these with the lowest common multiple, which happens to be 6. So I'm going to make sure that there's 6 nitrate ions, on both sides, meaning that I'm going to multiply the left side by 2, left side by 3, right side by 2. Jesus. All right, so I'm going to move this 3 in front of here with the lead. All right, 3 right there. I'm going to move this 2 in front of this aluminum right here. So my nitrates are balanced, but by adding those coefficients, I've made the aluminum and the lead unbalanced. Because remember, this 2 distributes to aluminum and the nitrate. So I have 2 aluminum on the the right side, only 1 on the left side. So I'm going to add a 2 right here. And then I have 3 lead atoms on the left side and only 1 over here. So I'm going to add a 3 right here. All right. So this would be the final answer of this problem. Okay. So it's 2 aluminum plus 3 lead nitrate, and that makes 3 lead and 2 aluminum nitrate, okay? When it comes to single displacement reactions, there's no need to worry about the solubility chart, okay? I only really want us to use this for the double displacement reactions, okay? Don't worry about it for single displacement. All right, so that would be my final answer for this problem, okay? So that is all I'm going to do for now. Remember, if you have any questions, please feel free to reach out to me at any time through my email. And remember, our assessment starts on Friday the 20th. Tomorrow, you guys will have one more review session, and then I will distribute your assessment so that you can complete it. And details on the assessment are to follow. So please stay tuned and make sure you're looking into PowerSchool Learning and checking your email.